I bet you're wondering why I'm standing here with a plunger.
No, but I'm sure you're going to tell me.
Absolutely right. We have a plumbing myth. Picture an old house, and in that house is an old hot water heater. The hot water heater is neglected. It's beyond neglected. In fact, so badly that it blows up. But it doesn't just blow up. No, this hot water heater blows up like a rocket shooting up through the roof of the house, hundreds of feet into the air, landing 500 feet away. The fans are going nuts about this on the website, and they want us to test it out.
Sounds like fun to me. It gets me all steamed up just thinking about it.
Water heaters are fitted with two main safety devices, a thermostat and emergency cutoff switch to prevent the water from overheating, and a temperature and pressure relief valve to release excessive pressure. To find out what needs to happen to make good water heaters go bad, Jamie and Adam are conducting scale tests using small 6-gallon tanks.
We're going to set this thing up using instrumentation that monitors both temperature and pressure. Then we're going to make each component, each safety component of this water heater fail until we get the entire tank to fail. Anyone have to go to the bathroom?
Improper installation or lack of regular maintenance can really cause the safety devices to fail. Jamie and Adam are just simplifying the process.
This is the thermostat and the emergency cutoff switch, which the water heater normally comes with. We've taken it off, so we've got no emergency shutoff.
The T&P valve is now the only functioning safety device. So here's how it works. When heated inside a closed environment, water expands and causes an increase in pressure. If the temperature or pressure gets too high, the T&P valve opens.
So in theory, once this thing reaches the pressure that the pressure relief or the temperature relief valve activates at, we should just see it start to spew some water.
Yep.
So people don't get scalded, the recommended set temperature for water heaters is well below boiling point of 212 degrees Fahrenheit.
Look at how fast the temperature's rising, man.
Yeah. Won't take long.
When the water gets up to a dangerous 165 degrees, the T&P valve comes to the rescue.
Oh, there it goes.
Really?
Yeah.
Oh, yeah, look, it's spewing. That's what it's supposed to do.
That's better. For their next test, they're really putting themselves in hot water.
What's next?
Well, next, I think we pull the T&P valve and we start the final failure analysis test in which nobody approaches this bunker until we hear boom or all clear. Now, you might wonder exactly how that's going to happen in real life, and I'm going to play it out for you. A homeowner looks at his hot water heater and sees that there's this thing sticking out in a pipe that doesn't go anywhere. And he thinks, well, maybe that's from some old plumbing. It's dripping water, too, so I'll just cap it, stop it from dripping water. It happens all the time.
Removing the T&P valve could cause a serious explosion. So Jamie rigs up an external emergency release so they can defuse the system immediately.
Are we live?
We're live.
All right, let's get everyone in the safety zone.
The pressure slowly builds. Normally, a T&P valve is set to release at about 150 psi. Now, the sky's the limit.
This is excruciating.
Tell me about it. 400 psi.
250 degrees Fahrenheit.
Both the temperature and the PSI are climbing steadily when all of a sudden...
Whoa. We just lost pressure. We lost half of our pressure over there.
Something in the system is causing the pressure to drop rapidly.
We're at 300 degrees Fahrenheit. I think we're losing pressure somewhere we can't see, and we've just got to abort.
All right, well, I'll pull the valve. That's what it's for.
All right, let's do it.
Jamie triggers his emergency release. When water that's been heated beyond boiling point hits air, it turns instantly into vapor. Great for opening those pores.
Okay, that is indicating it's fully depressured.
The PSI gauge just failed. Don't know why, but the main thing is neither Jamie or I feel comfortable doing the test here in the bunker anymore. After watching the amount of steam that came out, knowing how much pressure it takes to make a tank blow, we just want to be far away from this.
The pent-up fury inside this tiny tank has got the guys running for cover.
We need more room, for sure.
Let's pack up and move it out.
Okay.
Explosion danger lurks in thousands of typical hot water heater installations because the great majority have either improper protection or no protection at all.
Is the tale of the water heater rocket really true, or just over-the-top scare tactics? To find out, Jamie and Adam have arrived at the wide-open spaces of Alameda Naval Base.
It may help you to think about this in terms of just a pure release of energy. All we're doing is putting energy into the water heater in the form of electricity converted to heat. We're not letting that energy out in any way. Now, the difference between a rocket and a bomb releases all of its energy in every direction at once, and a rocket releases all of its energy over a little bit longer period of time in one single direction. And that's what we're looking for here.
The same as their scale tests, they're using a 6-gallon tank. And to recreate real-life circumstances of shoddy installation and neglect, have made a few adjustments.
The electronic cutoff switches and thermostats, gone. The temperature and pressure valve, gone.
The power from a remote generator is switched on.
Okay, Adam, we're live. We're hooked up. We're running about 25 amps, so everybody be on alert. Over.
And our little heater has his moment in the sun.
Well, as far as I can tell, everything's good to go.
I hope we get it to blow this time.
Yep.
I'm tired of watching a heater not do anything.
Third time's the charm.
In a healthy appliance, the cutoff switch would activate before boiling point, and the pressure release valve at 150 psi. But our patient is sick, and his temperature's rising rapidly.
All right, so we're at 7 minutes, almost 40 psi and 250 degrees Fahrenheit.
270 degrees, 53 psi. Okay, we're at 20 minutes, 370 degrees, and 190 psi.
Suddenly, his fever breaks.
That's a failure, but that's not an explosion. It was pretty spectacular. This thing bathed in a cloud of hot, scalding steam and 300, 400 degree water. It's ludicrously dangerous.
6 gallons of water turned into 9,600 gallons of fissering vapor. But even with all that force, the tank didn't go for a ride.
Let's get a bigger heater out here. Try this again.
Okay, let's do it.
A bigger tank may give the guys the heave-ho they need. Coming right up, besides looking killer,
Oh, those are good.
can an ordinary, everyday water heater become a rocket so powerful it can blast through a building? So far, Jamie and Adam have let off a lot of steam,
There we go.
Whoa!
but couldn't send a small 6-gallon tank skywards. This time, they're using a 30-gallon tank and have a new strategy to add some extra thrust.
I'd like to fill this 80% full.
Okay.
So let's put 24 gallons in here. We may find this like perfect relationship between water and steam for getting the maximum amount of pressure.
In daily life, a water heater is an appliance nobody normally takes any notice of. So to mimic one in serious neglect, Jamie and Adam disable its safety devices. Once again, it's time for launch and to man bunker boiling over.
By the time we're done with this, we'll actually know what we're doing.
At least one of our crew seems to think they'll get it this time. Never has a single water heater been covered from so many angles. Maybe all this attention will raise them from their D-list apparatus status.
Okay, now we're at 160 psi. It's officially a no-go zone. Anything goes from here on in, so stay clear.
These pressure vessel ones are really difficult because they involve tons and tons of waiting, and it's excruciating. It's really boring. The suspense is killing me.
After an excruciating 50-minute wait, they achieve liftoff.
Wow!
That was at about 350 psi.
The heater travels in a straight trajectory into the air so high, you could order a pizza